Good day everyone, welcome back to my channel. Today we'll be looking at pairs of lines and we'll be determining whether these pairs of lines are parallel, and we'll be giving reasons based on our findings. Now, for us to be able to understand this concept of parallel lines, it would be best practice to be able to understand a couple of things. For instance, number one, call this 1A. First example. So suppose you are given a figure you're given this figure here. Okay, and then you're given the lines. You're given line E, F, and you're given line S, T. Equally, you're given the following parameters. So you're given this angle here. You're told that this angle is 41 degrees, this angle here. And you're also told that this angle is an angle of 41 degree angle. Now, before one starts analyzing this example, or rather this problem, it would be best practice to first look into this mnemonic that reads fun. Now, for this application, we'll be looking specifically at this letter here, N, since this figure resembles this letter here, N. Now, to do that, it will be best practice in our instance to be able to devise a principle of this nature. So we have our principle here and hone our logic onto this rule. So we have angles. We call these are angles AB, angle CD, angle EF, angle GH, angle IJ, angle KML, angle MN, and angle OP. Now, there are very few pointers that I need to emphasize. Key areas of this principle. Now, for us to be able to identify this logic, starting on this N, okay, we need to identify that this figure here, like I said, figure EF and ST resembles N or Z in that matter. Now, by looking at this line EF and ST, before we actually conclude on the basis of whether these lines EF and ST are parallel to one another, we need to actually identify that we are talking about alternate lines, or rather alternate angles in this case here. So we have alternate angles. These angles are angles that resembles a Z, and we can actually immediately identify a couple of them on this figure. For instance, if I may have to draw a line there and draw another line there. Okay, so this looks like a Z already. It's a figure that resembles a Z. So meaning that this angle and that angle are alternate angles. So angle C and angle F are alternate angles. Let's use another color to identify another set. So we can actually already almost immediately identify another set. So we have a line there, another line there. So we have our Z once again. So here we have this angle and that angle there. So the angle D and angle E are also alternate angles. They are alternate angles to one another. So it's another set that I like to highlight. This angle here and this angle here. So angle K and angle N are alternate angles to one another. Also, these are two angles that are alternate angles to one another, angle K and angle N. So one last set of angles which are alternate to one another. We use an orange color. So we have this angle here and this angle here. Okay. This angle here and that angle there. So angle L and angle N. These two angles, angle C and F, are alternate to one another. Angle D and angle E are alternate angles to one another. Angle K and angle N are alternate angles to one another. And lastly, angle L and angle M are alternate angles to one another. So since these angles are alternate angles, and if this concept meets this criteria of alternate angles, it will mean that line EF, since these angles are equal, purely because they are equal, I have to emphasize that, since angle S and angle F are equal, which means it's the same resemblance of angle C and angle F. So it's the same resemblance of these two. This angle there and that angle, since they are equal, now we can start concluding on that basis that line EF is parallel to line ST. Okay, since only because that angle and that angle are equal. Angle C and angle F are equal. Okay, and then also because of this Z that we have, so it similarly applies to say that these two angles K and N, again looking at this Z kind of figure here, angle K and angle N, remember we're looking at these two, angle K and angle N are alternate angles, and since they are equal, it means that line EF is parallel to line ST. Now let's look at another example. Remember we just looked at a mnemonic that talks about, that only looks at N, in that case the Z and N, if that criteria or that logic meets that criteria of an n and an n, a z and an n rather, it means that those two angles, or the alternate angles, are equal. And if they are equal, it will then mean that the two lines are, or rather two pairs of lines are parallel. Okay, let's look at how this also applies on 1b, our second example. So in this case, we have almost the same approach, but slightly different. This time we're not going to look at n, but we're looking at another letter. So yeah. These angles. So now here, this time, I have to give you some of the details here. We have a 100-degree angle here. We have a 100-degree angle here. We have an 80-degree angle here. Okay, and then we given these angles. We're given angle E, you can call E1 and E2. Okay, and we're given angle F. Okay, and then we're given angle T. So we have T1 and T2. And then lastly, we're given angle S. So we're given angle S1 and angle S2. So those are simply the angles there. Okay, here we're given angle F1 and this side angle F2. So those are simply the angles, not the values. The numbers indicated in yellow are not necessarily the values, but the angles. So it's just the annotation of angles. So in this case, we have E1 and angle E2. And we have angle F1 and angle F2. And we have angle T1 and angle T2. And we have angle S1 and angle S2. So it's very important to identify those. And then in the color values indicated in orange are our actual angles. Those are the magnitude of angles. Okay, so to do that again, once again, let's first and foremost identify that our maths is a fun activity. So we just looked at this mnemonic. So we're going to look at a second mnemonic, which is now this time the U. So looking at U now. So in this case, we're going to still use our figure and devise our figure here. Okay. This is simply just to make it easy so that you know exactly if lines are parallel or not. So here, okay, we have angle A, angle B, angle C, angle D, angle E, angle F, angle G, angle H, angle I, J, K, L, M, N, O, P. Indicate O properly. So we have O and P. Okay, now to start devising, or rather annotating this again by observation, we can clearly see we are given the angles in yellow. So angles, the angles, the annotation of angles. So you have angle E1 and angle E2. Those are just for identification purposes. Angle F1 and angle F2. Angle S1 and angle S2. And angle S1 and angle T1 and angle T2. And then the actual angles are written in orange. Now, this time we're looking at co-interior angles. Remember in the first example, 1a, we looked at the alternate angles. So this time we're looking at co-interior angles. And all co-interior angles are supplementary. In other words, supplementary angles always add up to 180 degrees. That is very important to identify. All supplementary angles add up to 180 degrees, and all complementary angles add up to 90 degrees. But we're not going to look at the complementary angles in this instance. We'll be looking more into the supplementary angles. Now, to start now, annotating this now before we actually start, like I said, best to look at this example or the precept. This we already looked at. We looked at the n, any angle, or rather angles which are alternate angles in terms of z, or an n, these angles. So that first example passed that rule or that principle. Since it passed that criteria, then we could actually deduce on the basis of that or those results to say that the lines were parallel. So now we're looking at the second example. So the second example actually will require us to be looking at co-interior angles. Now, when you talk about co-interior angles, there are a couple of things that I like to highlight also here. Now, co-interior angles. For instance, when you look at angle, this angle here, we're given 100, so we have 100 degree angle plus angle E2, this angle here. Those angles are straight angles. So again, straight angles, I've got a video that I've posted earlier on with regards to lines, straight and lines and so forth. So in this case, we are actually looking at not necessarily straight lines in this case, or rather geometry that looks at straight lines or straight angles. So we are actually looking at whether these E2 and S2 are supplementary. So in this case, let's go ahead and find out to be able to find out whether E2 is actually supplementary to that angle, this angle. So we're going to have to use our algebra. So to do that, we're going to simply say make E2 our subject of the formula. Is equals to 180 degrees minus 100. Okay, so we have E2, 180 subtract 100 gives us 80 degree, and then which means that E2 is equals to 80 degrees. Okay, so that angle is an angle of 82 degrees, this angle here. Now we found that angle to be 80 degrees. So now moving forward, I'm gonna need to erase effect, need space here. Just eraser. Where's the eraser now? Oh yeah. It's eraser. This pen. I see. Just see. Okay, now let's look at, we still need to look at that same figure, so we actually can quickly highlight this. So we're still looking at 1b. So in this case we're given that figure, so our figure look like this. So given that, given that line there, this line there. Okay. Now we're given E1 and it's a different color. So even E1, no, we use yellow in initially. So you use yellow color. Okay, I think we should just stick to the same colors that we used earlier on. So okay, we have E1 and E2. Here we have F1 and F2. We have S1 and S2. We have T1 and T2. Remember, these are just simply the annotations. And then the actual values, we had 100-degree angle there. We had an 80-degree angle here. And we had an 100-degree angle here. Okay. So now, likewise, like I said, we already found this angle to be 80 degrees. Okay. Now, we at least now found an interior angle apart from the one that is given at S2. So now in this case, moving forward, we can now start using algebra right across to be able to find other missing values. Now, to find other missing values, remember, we have S, just for confirmation, we have S1 plus, oh no, let's actually use S2 because S1 is an exterior angle, so we're going to use S2 plus our angle E2, and remember, they should be supplementary to meet the criteria of co-interior angles. So in this case, we have 100. Angle S2 is a 100-degree angle plus angle E2 is an 80-degree angle. So that gives us 180 degrees. Since these two angles are co-interior angles and they give us 180, it means that these lines here, before we even conclude on that basis, we still have to find these angles here. Okay, let's actually use this moment to find those angles. So we have angle F, the exterior angle outside F there, we have 80 degrees plus angle F2 should give us also 180 degrees. This angle here, F2. So we already have 180 on this side, so we can go ahead and write it. So we have F2, which will become our subject of the formula. This 80 moves over to the equal sign, and then becomes negative 80 degrees. So we have F2 is equals to, that remains the side, and then we have 180 separated 80 gives us 100. So F2 is 100. So we have 100 degrees here. It's an angle of 100 degrees. So now 100 degrees, 100-degree angle here at F2. So F2, okay, again F2 plus, can actually use this also just to check, or rather to confirm, angle F2 plus angle E2 rather should give us 180. Okay, so F2 is 100 by substitution, 100 degrees plus E2 is 80 degrees. you can clearly see that those are supplementary angles, these two angles here, E2 and angle F2. Since they are supplementary angles, we now can confirm that that angle and that angle are parallel. Again, just to confirm the last angle, this angle here, okay, we need to actually find out if that is also the case. Now, remember the rule of all angles or all quadrilateral angles in the quadrilaterals, they all add up to 360. So in this case, we can now start going that far to the extent by saying angle E1 plus angle F2 plus angle T2 plus angle S2 should give us 360 degrees angle. Right, so now by substitution, we know that angle not angle E2, but not angle E1, but angle E2, because since it's an interior angle, this angle here. So in this case, let's go ahead and substitute. So we have angle E2 is 80 degrees plus angle F2 is 100 degree angle plus angle T2. This angle is unknown. Okay, you can just leave it there. And then angle S2 is 100 degree angle. So we're going to write 100 degree angle there. And then that all of this sum should give us 360. Should sum up to 360. So when you take your calculator and you add all of those values, so all the constants, so you have 80 plus 100 plus 100. That gives us 208 degrees plus angle T2. Remember, we want to find that angle is equals to 360 degrees. So by substitution, we remain with T2 is equals to 360 minus 280 degrees. So now, moving forward, we have 360 minus 280. We have T2, which remains now to be 80 degrees. Okay, so which means this angle here is equals to 80 degrees. So now let's calculate by summing everything up, and should give us exactly 360 to confirm our analogy. So now we have now angle E1. In fact, these are the angles that you need to sum up to give you the answer holistically. All of these, after you sum them up, should give you 360. Right, so we're going to go ahead and punch all of these values in the calculator. So we have 80 plus 100 plus 100 plus 80, and that indeed gives us 360. So this means which means that angle E2 plus angle F2 plus angle T2 and angle S2, the sum of all of those angles sum up to 360 degrees. And then lastly, let's look at this example. Looking at example 1C. Example 1C. and example 1c. Example 1c. There you go. Now we're looking at example 1c. Now, when you look at example 1c, we're given a figure almost similar to the figure we have been given in 1b. So this time we're given this figure. Okay, and then we're given actual angles. So the angles are, okay, we have angle E, angle S, angle T, and angle F. Okay, just to highlight these angles, we have E1, and we have angle E2, angle F1 and angle F2. We have angle T1 and angle T2. We have angle S1 and angle S2. Okay. Just notice that the subsidiary of these angles, E, the interior angles, or rather the angles within the figure itself, or the quadrilateral itself, at E is 2. And at angle S, the interior angle is 2. And angle at F, the interior angle is 2 as well. And the angle T, the interior angle is 2. So what this what it means, those are the angles at those points. At angle E, S, F, and T. Now, we are also given the actual values. I need to indicate the values now. Actual values that are given are 61 degrees. We're given 119 degrees angle. We're given 121 degree angle there. So those are the 3 angles that are given. Now we need to find or determine whether there are pairs of parallel lines in this figure. Now to do that, again, we just looked at cointerior angles for the second example, or example 1b. In example 1a, we looked at alternate angles. So now to find or determine whether in this figure we have sets of pairs of parallel lines, we're going to actually start looking at our algebra now. We can just straight jump into algebra in this case. So we can simply say S2, or rather angle S2 plus this 121 exterior angle.
It's 21 hours.
Equals to 180 degrees. Now, only because those are straight angles, or angles on a straight line. So angle S2, you can just simply make it the subject of the formula, is equals to 180 degrees minus 121 degrees. So by use of a calculator, we can just simply punch the 180 subtract 121. 121 gives us, so in other words, angle S2 gives us 59 degrees. So this angle here, an angle of 59 degrees. Okay, that's angle S2. Only because the angles on the straight line, these angles, only because the angles on a straight line, this angle plus this exterior angle, are supplementary. Okay, so now we have angle S2. Now moving forward, we need to find other angles, so we can just simply use this since we are given the exterior angle here, this angle here. We need to find this angle here, which is angle F2. So to find angle F2, we are given 119 degrees plus angle F2 should give us 180 degrees, since those are angles on a straight line. These angles, they are supplementary. So now we have angle F2 is equals to 180 minus 119 degrees. So by use of a calculator, we just simply punch there 180 minus 119. That gives us angle F2 to be 61 degrees. So here we have an angle of 61 degrees. So here this angle here, 61 degrees. Angle 61 degrees. Okay, so that's what it means. Okay, in fact, let me highlight this properly so that we see exactly what is it that you are working with. This is the color. So we have angle of 61 degrees here. This is 61 degrees. Now we have that angle there. So now since we have two angles already, 59 degree angle and a 61 degree angle, so we are ready to go. So we have another angle there, so we can just use that as a supplementary angle. So we have angle 61 that is given there, 61 degrees, plus angle E2 should give us 180 degrees as well. So making E2 the subject of the formula, we already have 180 minus 61 degrees. So 180 minus 61 gives us, so which means angle E2 is equals to 119 degrees. So this angle here is a 119 degree angle. So now we can use the concept of co-interior angles once again, since now we already have angle E2 and angle S2. So moving forward, so we can just simply say now, just to confirm our calculations, we can just simply say angle E2 plus, it should be S plus angle S2, this angle here, is equals to 180 degrees. Those are co-interior angles. If this application meets this criteria or this approach of being supplementary, these two angles being supplementary and these angles being supplementary, it will mean that these lines are parallel. Line ES and line FT are parallel to one another. So let's go ahead and calculate. So we have E2. In this case, we found that to be 119 degrees plus S2. We found that to be 59 degrees. Let's see how much this gives us. 119 plus 59. That gives us 178. So that gives us 178. Okay. So in other words, this angle here plus this angle gives us 178. Okay, let's check how much does F1 and E2, how much does F2 rather and angle E2 give us or yield. Okay, we can go ahead. So we already found that these angles and we already discovered that angle E2 E2 is 119 and angle S2 was 59. And then adding these two up or summing them up is 178. So let's add angle E2 and angle F2. So angle E2 plus angle F2. Let's see how much they give us. So we have the sum of those two angles. We have 119 degrees plus 61 degrees. Let's see how much we get. 119 plus 61, it gives us 180 degrees. So that angle and that angle gives us 100. The sum of those angles gives us 180 degrees. Now moving forward, we can now move on now by confirming the last angle. Okay, in this case, we know that we can use the concept of, okay, we just look at cointerior angles, these angles, angle F2 and angle E2 are cointerior angles. So now we can also look at another aspect that I like to emphasize also. We use another element of finding out if those lines are parallel. Okay. So let's actually look at some of this or this. Okay. Okay, now we are almost done with the last example. So we saw that angle E2, angle E2 angle E2 plus angle F2, they gave us 180 degrees. We saw that because 119 degrees plus 61 degrees gives us 180 degrees. We saw that. Now, and we saw that also that angle E2 plus angle S2, okay, didn't necessarily give us 180 because we saw that 190 degrees plus 59 degrees, we saw that it gave us 178. In other words, that doesn't necessarily necessitate that those are parallel lines. Because of this discrepancy in our application, it means that line ES is not parallel to line FT. Then we can start concluding on that basis because of this answer here. Okay, so that brings us to the end of our lesson for today. Please like, share, and subscribe to this channel so that I can be able to create more content. Thank you for watching. Goodbye.